Lesson 3, Quadrilaterals. So a quadrilateral is a four-sided polygon. It has four sides. So there's lots of different types of quadrilaterals, and here is a list of the formulas of ones that we might have to solve for. And they should be all ones that you are fairly familiar with. I'm not going to go through each of them, but we will use them as we go. So we'll do example 1. So just so you know, when you're calculating the volume of something, you're going to do the area of the base times the height. But this first one is telling us to calculate the volume of a prism that has a base of 10 meters by 4 meters and a height of 2 meters. So it's a prism. We're going to assume it's a rectangular prism because it just says length times width times height. So we have 10, 4, and a height of 2. Determine the capacity, sketch the prism and the net, and what could this prism be used for? So the net of this, if we unfolded it, would look like this. And you can label those if you want, but I'm sure we could figure that out. But there's our unfolded net. So we're going to find the volume of this. So the volume is going to be the area of the base times the height. So our base is a rectangle, so we have length times width times our height, so length times width times height. So we have 10 times 4 times 2. And 10 times 4 is 40, times 2 is 80. And because we're dealing with meters and it's a volume, it is meters cubed. Capacity helps us because it tells us in a liquid form, so we're not really so great with meters cubed, but changing it into how many liters that would be. So 1 meter cubed is equal to 1,000 liters. So we have 80 meters cubed, and we're going to go x. So we're going to cross multiply and divide. So across 80 times 1,000 divided by 1, and you should get 80,000 liters. So thinking about 80,000, that's a pretty big number. It's probably going to be something like a swimming pool, which would make sense for this shape and size. And I like swimming pools, so let's hope it's that. Alright, example 2. You're building a water trough for cattle using a shape that's containing 2 parallelograms and 2 isosceles trapezoids and a rectangle. The length of the entire trough is 1.75 meters. The height of the trough is 0.3 meters. The top of the trapezoid is 0.55 meters. The bottom is 0.4. And then it gives us all the angles. So it's asking us to prove all of these shapes. So we're going to sketch this. So we have a trough. It looks kind of like that. So basically when we unfold it, we have a rectangle with 2 trapezoids on the ends. And then we have the edges, and then we could either have a top or a bottom if necessary. But the top would be bigger if you needed it. So let's look at all of these distances. So let's just look at the trapezoid first. So the trapezoid tells us that the top is 0.55 and the bottom is 0.4. And we know that the height of the trough is 0.3. So you can label that on here if you want to. We also know that the angles are 76, 104, 76, and 104. So these ones would have to be 76 because these are obtuse angles. And these would be 104, and this would be 76. So I can tell this is a trapezoid, and especially an isosceles trapezoid, because I have 2 equal angles and 2 equal angles right here. So that makes it a trapezoid. For the bottom of the trough, that would be easy. So this bottom right here, we know that it would be 0.4, and then the length of the trough, which is 1.75. So this is going to make right angles, and this side and this side are all going to match. So this is going to be a rectangle. So that shape is pretty set. For the sides here, these two sides are going to be the same, but in order to figure it out, we need to actually know this side of that triangle. So we're going to look at this little triangle right here. So we've got this little triangle right here. There's 90 degrees, and we know that this bottom angle here is 76. I flipped it around. And we know this height is 0.3. So we actually can use this to find the hypotenuse. So we're going to label our sides. This is the H. From this angle, this is our opposite side. When we have an O and an H, we are going to use so. Because x is on the bottom, it's the h value on the bottom. When x is on the bottom, we divide. So we're going to take 0.3 and we're going to divide it by the sine of 76. And that will give us our x value. And the number we get there is 0.31, so it's a little bit bigger than the height. So that means that this is 0.31, this is 0.31, all of these sides are 0.31. So our second rectangle that we're dealing with, it's still 1.75, but the lengths is 0.31. And then the top, this top right here, if there was a lid, this one has a length of 1.75 and it's as big as the top of the trapezoid, so it would be by 0.55. So we can actually find all those dimensions quite easily. Okay, so part C, or B and C is asking us to figure out how many liters the trough will hold. So we're going to do the area of the base times the height. So the area of the base is the area of a trapezoid. And if you're unsure on what that formula was, you should be able to look at the front. Mine doesn't show it for some reason, but it's A plus B divided by 2 times the height, and then times the height of the trough. So this height here is representing the height of the trapezoid, whereas this height here is representing the height of the whole trough. So we actually think about it like it's sitting on its side, not how it would actually sit. So we're going to plug all of these numbers in. So we have remember that A and B is just the top and the bottom of the trapezoid. So we have 0.55 plus 0.4 divided by 2 times the height of the trough, which is 0.3. And then we're going to times that by the height of the whole thing, which is 1.75. So type all this in together. When you type this plus this, push your equal sign before you hit divided by 2 so that your calculator does proper bed mass. But if you type all of this into your calculator, the number you should get is 0.25 meters cubed. Now using our conversion, we know that 1 meters cubed is 1,000 liters. We have 0.25 meters cubed. We're looking for x. We're going to cross multiply and divide. So the number we should be getting is 250 liters. Okay, we're just going to go through each of these shapes and determine which things are the same. So on a parallelogram, we have two sets of congruent sides. So these two are congruent and these two are congruent. It has two sets of parallel lines, which means that this is parallel to this and this is parallel to this. So both of these is 2 sets. Angles that will be equal are the opposite angles. So this angle and this angle will be the same, and this angle and this angle. So opposite angles. And our diagonals, if we think about the diagonals, I'm just going to erase all of this. If we think about our diagonals, they will bisect each other. They will cross exactly at halfway. Oops. And when they bisect, it's going to make, again, a couple sets of equal angles. So those two would be equal, and those two would be equal. So again, 2 sets of equal angles. A rhombus, all the sides are equal. So it's like a square, but they're on an angle. So all equal sides. For parallel lines, we're going to have 2 sets of parallel lines. So this side's going to be parallel, and this side is going to be parallel. For our angles, we're going to have the same thing as a parallelogram. We have 2 sets of opposite angles, so this side and this side, and this side and this side. When we look at the diagonals, our diagonals will bisect each other, just like a parallelogram. But in a rhombus, they will bisect each other and make 90-degree angles. So they bisect each other and they make 90-degree angles. And now a kite. Just so you know, we would call this side A and this side B in a parallelogram. In a rhombus, they'd be all the same side. In a kite, we have 2 sides and 2 sides. And what it is it actually makes 2 isosceles triangles. So we have 2 sets of congruent sides, just like the other ones. There is no parallel lines in a kite. Nothing is parallel. For our angles, we can put that it makes 2 isosceles triangles. And we'll have 1 set of equal angles, and our equal angles are going to go here and here. These two do not have to be the same. We only have one way to make a diagonal in a kite, and the way that that works is down this way. It splits it in half, and like the one I had before, and it also makes a 90 degrees. But it does not bisect it because it doesn't make it hit exactly in 2. So those are kind of our 3 big shapes that we use. So using this knowledge, we're going to prove all of this. So first of all, this is a parallelogram. I can tell because it has 2 sets of parallel sides and what appears to be 2 different sets of angles. So in this parallelogram, first you need to know that all angles have to make 360 degrees in a quadrilateral. All quadrilaterals make 360 degrees. You can remember that because a square has 4 90-degree angles, which makes 360. So in this parallelogram, I would know that because this one is 42, this one also has to be 42. So to find angle D, it's going to be the same as angle B, which means we can take the difference and divide it by 2. So we're going to go 360 minus 42 minus 42, and then divide that number by 2. And we would get 276 divided by 2, which is 138. So this is 138, and angle B would also be 138. For the next one, we have a trapezoid, and because this side is equal to this side, it is an isosceles trapezoid. And because they're the same, if this side is 15, then that question mark is also going to be 15 feet. For the next two examples, we have a kite. So we have, to find that last angle, first of all, we can call it a kite. And we're going to take 360. Actually, it's not really a kite because this and this aren't the same. So this is just a quadrilateral. I lied. Got ahead of myself. So we're going to take 360 and subtract all of the angles that we have. And whatever is left over is how big that last angle is, and it is 112. Alright, and the last one, they're all equal sides, which means we're dealing with rhombuses and squares. So first of all, this one right here is a square because all of the sides are going to be 90, because if that one's 90, the rest are 90. And this one right here is going to be a rhombus because the angles are going to be different. And you can't really solve anything because we don't have any lengths, but we do know that all of these angles would be 90.